analyze a position versus time graph. What we'll do is find displacement and look at the relationship between position, displacement, and distance as functions of time. Then we'll look at finding the velocity from a position versus time graph, specifically the relationship between velocity and speed. Then we'll look at finding the average velocity and the average speed. Remember that, in general, position is a vector that relates to the origin. Here we're graphing x versus t, which just denotes one-dimensional motion. Displacement is a vector that denotes change in position. Distance is just the scalar that tells how far you traveled without giving direction. Velocity is a vector that denotes speed and direction. And here we're seeing that velocity is the slope of a position versus time graph. And speed, remember, is just the magnitude of the velocity. Let's analyze what's going on at t equals 1.0 seconds, where the red dot is. The position is 1 meter away from the origin, so that's 1.0 meters x hat. The total displacement is also 1 meter away from the origin, because if you started from the origin, then you would have gone 1 meter, and the total distance traveled is also 1 meter. The velocity is the slope, delta x over delta t, which is 1 over 1, giving you 1.0 meters per second, also in the x hat direction, because it's positive. At t equals 2 seconds, the position is now 2 meters, and the total displacement is also 2 meters. And the total distance traveled is 2.0 meters as well. We're 2 meters away from the origin. Now it's a little bit hard to know what the velocity is right here because the slope is changing. If we take it to be the flat line that follows, then we'll say that the velocity is 0.0 meters per second. It's a little bit hard any time that you're analyzing a graph that has corners because there's basically a discontinuity in the slope right there. At t equals 3 seconds, we're still well along that flat line. Basically, we're just staying still without moving at all. Our x is not changing at all, so our position is still 2 meters in the x direction. The total displacement is 2 meters in the x hat direction, and the total distance traveled is still 2 meters. The velocity, however, is 0.0 meters. If you take the slope right here, you can see it's a zero slope. At 5 seconds, you can see our red dot is moved back to the t-axis. That means that the position is 0 meters. And the total displacement is also 0 meters, but the total distance traveled here is 4 meters. We've actually gone 2 meters away from the origin and then 2 meters back, so that total distance traveled is 4 meters, even though the total displacement is 0. The displacement started at where x equals 0, ended at where x equals 0, so the total displacement is 0. The velocity, if we take the slope of the line at that point, we find that it's minus 4 for x final minus x0 over 2, which is t final minus t0, giving a slope of negative 2 meters per second. So our velocity is negative 2 meters per second, and our speed is just 2 meters per second. At 7 seconds, our position is negative 2 meters x hat. We can see that we're 2 meters below the t-axis. We've traveled 2 meters in the negative x direction. The total displacement is negative 2 meters. The total distance traveled is 4 meters because we went 2 meters in the positive x direction, then 2 meters in the negative x direction, and then stayed still. The velocity here is 0. You can see the slope of the line right here is 0. At 10 seconds, what do you think the position is, the total displacement, the total distance traveled, and the velocity? I'd like you to work on this. Just turn off the video for a second. See if you can come up with these values on your own. Let's start by finding a velocity in the increment between 8 seconds and 11 seconds because our velocity is constant there. So if the velocity is the rise over the run, x final minus x0 over t final minus t0, x final minus x0 is -1 minus -2, or 1, and t final minus t0 is 3. So 1/3 meter per second is our velocity over that increment. Now let's find what our displacement is from 8 seconds to 10 seconds, where our dot is. To do that, we take the velocity times delta t. The velocity is 1/3 meter per second. Delta t is 2 seconds, giving us 2/3 meters, because the seconds cancel. If we traveled 2/3 of a meter from 8 seconds to 10 seconds, that means we're now -1 1/3 meters in the x-hat direction. The total distance traveled, however, is very different. It's 6 2/3 meters. So we went in the positive x direction for 2 meters, then in the negative direction for 4 meters, for a total of 6, and then 2/3 of a meter back in the positive x direction. That means that we actually have gone 6 2/3 meters. Now let's look at what's going on at t equals 12 seconds. I'd like you to stop the video and do this calculation yourself, if you would. Find the position, total displacement, distance traveled, average velocity, which is total displacement over the time increment, and average speed, which is total distance over the time increment. We find that our position at 12 seconds is -1 meters. We also have total displacement at -1 meters in the x-hat direction, and the total distance traveled is now 7 meters. We went 7 in the positive direction, then 4 in the negative direction, and then 1 meter back, which is a total of 7 meters. So for our average velocity, since we went -1 meter in 12 seconds, that gives us an average velocity of -1/12 meters per second. Our average speed is 7/12 meters per second, because we went a total of 7 meters in 12 seconds. Now let's look at this in another way. Imagine if you were walking this path, what you would be actually doing while you were walking. What I'd like you to do is stop the video and actually write down a few bullet points in words to describe your walking path. Here's the way I said it. We started at the origin. If we take the positive x direction to be in the right, then we walked 2 meters to the right at a leisurely pace and stopped. We stood still there for 2 seconds. Then we walked fast to the left for 4 meters and stopped and stood still there for 2 seconds. Notice we went through the origin when we did that. Then we walked slowly 1 meter to the right and stopped and stood still for a second. To recap, in general, the position is a vector that relates to the origin, and displacement is a vector that denotes change in position. Distance is a scalar that tells you how far you traveled. Velocity is a vector that denotes speed and direction, and velocity is the slope of a position versus time graph. Speed is the magnitude of the velocity. Average velocity is total displacement divided by the total time. Average speed is total distance divided by the total time. Thank you kindly for coming. Please come again soon.